The essential question, how can you write general rules involving properties of exponents? So just as a quick reminder, going back to the idea of addition, the reason I'm doing this is people get this confused, is repeated addition is multiplication. 3 plus 3 plus 3, there's a plus sign in between, is the same thing as 3 times 3. So when you repeat addition, it becomes multiplication. So what an exponent is it when you don't repeat addition, but you repeat multiplication. Like 2 times 2 is 2 to the second power, which is 4. 2 times 2 times 2 is 2 to the third power, and that's 8. So just a quick reminder of what an exponent, or some people call power, actually is. So then looking at that, let's kind of build on this idea and talk about zero exponent. Okay, so zero exponent, what is that? That's for any non-zero number, a, where a is to the 0 power, it equals 1. So the power 0 to the 0 power is undefined. So if we had 4 to the 0 power, it equals 1, because any non-zero number, well, 4 is a non-zero number. If you have a to the 0 power, it would equal 1 as long as the a didn't equal 0. So as long as it's not 0 to the 0 power. So if I had 5 to the 0 power, what would that equal? It would equal 1. If I had x to the 0 power, what would it equal? It would equal 1 as long as that x is not a 0. As long as it's not a 0 to the 0 power. Okay. You might say, well, how come it equals 1? I'm going to attach a link to a video that will go into more explanation on that, but just for right now. And I'm not going to attach it to the YouTube video, but to the actual video you do in class, the Edpuzzle. But if you look at 2 to the second power over 2 to the second power, just as a quick explanation, there's two ways you can know it equals 1. One way, though, is that anytime you have the top numerator the same as the bottom denominator, it always equals 1. So that's one way you can know that it equals 1. Because 2, and we're going to talk about this in a second, is when you divide exponents with the same base number, you just subtract. Well, 2 take away 2 is 0. So in this case, 2 to the 0 power equals 1. All right, that may have been a little confusing. Like I say, there's a video, and also we'll talk a little bit more about that division concept in a second. Why a non-zero number? Well, think about it. If you had a 0 there, 0 to the 0 power would be the one exception where it wouldn't be 1, because 0 to the 0 power is still 0, right? Okay, so looking at this here, for any integer n, for any this is the negative exponents, it says for any integer n and any non-zero number a to the negative n is the reciprocal of a to the n. So for any number n, for the n they put a 4 this time, and any non-zero number a, so 4, it's a non-zero. So 4 to the negative 2 would just be the reciprocal of that 4. And then you would cause it to be a positive. Okay? So pretty easy. If I had, well, I could choose any number. I usually call on students right here, but let me just choose a number real quick. So if I had 5 to the negative 2 exponent, it would equal 1 over 5 squared. It'd be a positive, not a negative anymore, and you'd put it in the reciprocal. Since it's 5 is the same thing as 5 over 1, you would now flip it and put it in the denominator. So you just do the reciprocal and keep the exponent. And of course, 5 times 5 would be 25. So the answer would be 1 over 25. Sorry, guys. I'm getting some text messages here. So, and again, why a non-zero number? Because if a zero number was in the denominator, well, 0 in the denominator is what? It's undefined. Okay, so let's go ahead and practice some of these concepts here. So if we have a 6.7 to the 0 power, well, anything to the 0 power equals 1. Easy. That's the answer. We're done. And then if you have a negative 2 to the negative 4, remember, exponent negative 4th power, you would write the reciprocal. So you would have a negative 2 in the denominator, because right now it's in the numerator, to the 4th power over 1. Of course, you're not done. You can still say what a negative 2 to the 4th power is, right? So what is a negative 2 to the 4th power? What's a negative 2 times itself 4 times? That would be a 16. So the answer would be 1 over 16. And remember, whenever there's a positive number, negative 2 times a negative 2 times a negative 2 times a negative 2. Whenever there's a positive number, or even number, it's always a positive when you have negatives. Because a negative times a negative is a positive, times a negative is a negative, times a negative is a positive. So it would be a positive 1 over 16. Okay, let's take notes on these two. So anything to the 0 power, as long as it's not a 0, is 1. So go ahead and write C in your notes, since 1. And then D, since it's a negative exponent, we're going to put it in the denominator and make it positive, right? So it'll be a negative 3 to the 2nd power in the denominator. Now the negative 3 is still negative, but this exponent is no longer negative because we did the reciprocal. And then a negative 3 times a negative 3, of course, would be a positive 9. All right. Let's try this next one here. Simplify the expression 4x to the 0 power over y to the negative 3rd power, and write your answer using only positive exponents. Now, why is it saying to use only positive exponents? Well, because there's nothing wrong with writing a negative exponent. It's certainly okay to do, but it wants you to write it as a positive this time. So it's not asking you to simplify it, it's just saying write it as a positive. So in this case, let's start with the numerator. Anything to the 0 power, as long as it's not at 0 itself, is a 1. So that x to the 0 power is really like saying 4 times 1. And then that y to the negative 3rd power, we just do the reciprocal. Now, since it's in the denominator, we need to move it to the numerator. So the answer to this would be 4 times 1 is 4, y to the 3rd. And that's the answer. Okay, take notes on this one. So let's start again. 2 times 0 would be 1. So we'd have a 1 there. And then 1 times x to the 2nd would just be x to the 2nd. But y to the negative 2nd power is in the denominator, but since it's negative, we just do the reciprocal and move it to the numerator. So it'll just be y to the 2nd in the numerator. That's your answer. Okay, and again, I probably should have been naming the reason why. So again, this is called the zero, the definition of zero exponent is when you multiply something by 0 and it ends up being a 1. And then the definition of negative exponents is how you're able to do the reciprocal. So you have in the denominator, you decide to put in the numerator, you've done the reciprocal, and so that's the definition of negative exponents. I want you to go ahead and try this, so go ahead and give it a shot, answer these questions, put it in your journal. Okay, so we can keep going here. There's a couple other properties of exponents here. The product power of powers property, and this is let A be a real number and let M and M be integers. To multiply powers with the same base, add their exponents. So in this case, notice that they have the same base number, 4. But what's different is the exponents. But how do you multiply these exponents when they have the same base? It's so easy, you just add. If they have the same base number, you just add them. And we'll stop right here, because we are running out of time. And we will pick this up in the second part in just a second here. Whoops.